Welcome everybody. We've been given this question: f of z is equal to z cubed positive az positive 52. Given that 2 negative 3i is the root of f of z is equal to 0, write down the other complex root. Now, first knowledge point: complex roots occur in conjugate pairs. So that means if 2 negative 3i is a root of f of z, and this means, so 2 positive 3i will also be the root. Of f of z. Okay, so that is the first question. Write down the other complex root. So I have given you the other complex root. So this is for section A. Now we are expected to solve, right? So let me just go to B. In B, what are we asked? We asked to solve f of z is equal to 0. Is equal to 0, we need to get the other root. We need the other root. Why? Okay, since the degree is 3, we have been given z cubed here. Okay, so we have already got root 1. So let me write that down. Root 1 is 2 negative 3i. We have got root 2, that's 2 positive 3i. Now the third root, I'm going to take it as some r. Now we know that the sum of the roots, right? We got a formula. The sum of the roots for z cubed positive az positive 52. Now you see here the second term is missing. So that would mean if I were to take 2 negative 3i, add it up with 2 positive 3i, add it up with r, that is going to be equal to 0, right? So you add these two together, this and this gets cancelled, we get 4 positive r is equal to 0, therefore r is equal to negative 4. This means the third root is equal to negative 4. Now you might be wondering, why do we need to find the polynomial f of z? Because they are asked us to get the value of a. So let me show you. To get f of z, how do we do that? Now let me, okay, I hope you can see this. So we know that, what do we know? We know that 2 negative 3i is a root. This would mean z negative of 2 negative 3i is a factor. Also 2 positive 3i is a root. This means z negative of 2 positive 3i is a factor. Okay, so also we got another root. We got negative 4 to be a root, right? Also we have negative 4 to be a root. So this would mean z positive 4 is a factor. So therefore f of z is equal to z negative of 2 negative 3i. We got to multiply to get the polynomial. Z negative of 2 positive 3i times z positive 4. Now I will club these two together. Now this is, I'm going to rewrite this as z negative 2 positive 3i multiplied with z negative 2 negative 3i times z positive 4. Now this is a positive b multiplied with a negative b, which is a squared negative b squared. So this is going to give me z negative 2 the whole square negative 3i squared, of course multiplied with z positive 4. Now you expand this, this will give you z squared negative 4z positive 4. The I squared is negative 1. This is 9, so it's going to be positive 9 multiplied with z positive 4. So you can add these two together. So you get z squared negative 4 times z positive 13 times z positive 4. So you multiply everything. So this is going to be z cubed positive 4 times z squared negative 4 times z squared, and then you have negative 16z, and then you have 13z, and then you have 12 152. So clearly this goes up. So you got negative 16z, you see that, and that has to be added with positive 13z, so that would give you negative 3z. So I'm going to need a paper. So this is equal to z cubed negative 16z added with 13z is negative 3z positive 52. Now originally f of z is given to be as z cubed positive az positive 52. So this means a times z is equal to negative 3z. So therefore a is equal to negative 3. Okay, I hope you got that value for a. Now we need to plot an argand diagram. So the first root, what is the first root? We got 2 negative 3i, so that will be plotted as 2 comma negative 3. Then 2 positive 3i, that will be plotted as 2 comma 3, and then you got negative 4, so that will be plotted as negative 4 comma 0. So this is the real z, imaginary z, and then if I were to take 2 here, 3 here, negative 3 here, 2 comma negative 3, so 2, the first point, negative 3, that will be over here, 2 positive 3, that will be over here, and then negative 4 comma 0. So 1 2 3 negative 4, this point is 0. Okay, so that is the final answer. Okay, so we got question number 2. We are expected to find the value of x given that 64 cos raised to the power of 4x negative 64 cos raised to the power of 2x negative 9 is equal to 0. You are expected to give your answer in the form of q times ln 2. Now foremost, let me just take cos squared x is equal to sum p. So I will take this as 1, therefore 1 can be rewritten as 64 cos squared x, and okay, I need to make one more alternative. So 64 times cos squared x negative 9 is equal to 0. Now there is 64 there, so what I'm going to do is, instead of writing it as cos squared x is equal to p, let me take this substitution. 8 times cos squared x is equal to p. So that would mean this can be rewritten as 8 times cos squared x, right, raised to the power of 2. Fair enough. When you square 8 you get 64, and this one will give us to the power of 4 negative. Similarly 8 times cos squared x, right, so I need to place the 8 here, negative 9 is equal to 0. So because of the substitution, this, if I'm taking it as 2, therefore 2 can be rewritten as p squared negative 8 times p negative 9 is equal to 0. So therefore by quadratic p is equal to 8 plus or minus root of 64, negative negative positive, 9 4s are 36 divided by 2. So this one added up will give you 100. So you get 8 plus or minus root of 100 divided by 2, which is going to be 8 positive 10 divided by 2, which will give me 18 divided by 2, which is going to be 9. Okay, so one value is 9, the other value, this is 8 negative 10 divided by 2, negative 2 over 2, that's going to give me negative 1. But what is the value of p? P is 8 times cos squared x, right? So that would mean 8 times cos squared x is equal to, you got a 9. Now this value negative 1, this is going to give me a negative output. right? So let me show that to you. So over here you have 8 times cos squared x is equal to negative 1. So when you got one solution here, the other one is negative 1 over 8. Now this negative 1 over 8 is not in the domain of the hyperbolic cos. So we need to drop this because of the fact I have just mentioned to you. Actually root of 9, so it's going to be 3 times, or I would say 3 over, root of 8 is 4 times 2, I have a square root, so it's going to be 3 over 2 times root 2. Right, so this is my cos x, but the requirement is x, but we know that cos x is e raised to the power of x, positive e raised to the power of negative x divided by 2. So substitute that there. So if I were to take this as 3, therefore 3 is going to be e raised to the power of x, positive e raised to the power of negative x divided by 2 is equal to 3 over 2 times root 2. 2 gets cancelled. Now this is rewritten as e raised to the power of x, positive 1 over e raised to the power of x is equal to 3 over root 2. Now take the LCM, you get e raised to the power of x, that's going to be, okay, I'll write it as e raised to the power of x, the whole squared, positive 1 divided by e raised to the power of x. Now you have a root 2, so place the root 2 there, and you have a 3 there, so you cross multiply. Let me go to the next side. So now what I'm going to do is, I am going to rewrite this as root of 2 times e raised to the power of x the whole square, positive root of 2 is equal to 3 times e raised to the power of x. So move everything to the other side. So it's going to be e raised to the power of x the whole square times the root of 2, negative 3 times e raised to the power of x, positive root of 2 is equal to 0. Now let me take e raised to the power of x is equal to t. This means you have t squared and you got a root of 2, negative 3 times t, positive root of 2 is equal to 0. So if I were to divide everything by root of 2, this is going to give me t squared, negative 3 over root 2 times t, positive 1 is equal to 0. So therefore the value of t is equal to 3 over root 2 plus or minus root of 3 over root 2 the whole square, negative 4 times a times c divided by 2 times a. So this is going to be 3 over root 2 plus or minus root of, now this is 9 over 2 negative 4. So this is going to be giving me 3 over root 2 plus or minus 2 times 4 is 8, so 9 negative 8, that is going to give me 1 over 2, right, divided by 2. So I have 3 positive root 2, positive 1 over root 2, now there is a 2 there, or the other one is 3 over root 2, negative 1 over root 2 divided by 2. So 2 things are there. So from here I will have a 4 over root 2, and this 2 comes over there, so it's going to be 2 times the root of 2, so 2 will divide this for 2 times, so this is going to give me 2 over root 2. So that is one value of t. The next value of t, in this case I will have 2 over root 2, and I have a 2 there, so 2 gets cancelled, so I get 1 over root 2. So I got t is equal to 2 over root 2, that's one value, and t is equal to 1 over root 2, that's the other value. But now the question is, we have to, so let me write that down, t is equal to 2 over root 2, t is equal to 1 over root 2, but what is t? Okay, so we need to know the t. So my t is e raised to the power of x. So I have e raised to the power of x is equal to 2 over root of 2, and then e raised to the power of x is equal to 1 over root 2. Okay, now I can actually consider this first. So let me just consider this first. Now this is going to be root of 2 times root of 2 divided by root of 2. They get cancelled, so e raised to the power of x is equal to root 2. This is going to be, I can just take it as just 1 over root 2. Never mind, let us just have it as it is. Now over here I'll take ln both sides, ln and ln. Take ln both sides. So if you were to take ln both sides, this is going to be x times ln of e to the base e. Now this is ln root 2 is 2 raised to the power 1 over 2, right? So now ln e to the base e is equal to 1, so this is going to be x is equal to, and also ln a raised to the power b is equal to b times ln a. So by this formula this is going to be 1 over 2 times ln 2. So this is 1x value. Now coming back to the other one, so you take ln both sides, so you get ln of 1 over root 2. Now ln of a over b is ln a negative ln b. So by that this is going to be ln 1 negative ln root 2. Now this one vanishes, so you get a negative ln of 2 raised to the power 1 over 2. So that would mean negative 1 over 2 times ln 2. On this side you get x because of this same explanation. Okay, so you have two values. So this is one value and this is the other value. So please like, share and subscribe. Welcome everybody. This is question number 3. We are expected to solve this differential equation. So the question is, determine the general solution of the differential equation cos x times dy over dx positive y times sin x is equal to e raised to the power 2x times cos squared x. Giving your answer in the form y is equal to f of x. We are also given a condition y is equal to 3 when x is equal to 0. So we will first solve the part A. So I'm going to start off like this. Solution. We are given cos x times dy over dx positive y times sin x is equal to e raised to the power of 2x times cos squared x. I will divide throughout by cos x. So dividing by cos x, dividing by cos x, and dividing by cos x. So a cos squared and a cos x gets cancelled. Cos x gets cancelled. We get dy over dx positive y times sin x over cos x is equal to e raised to the power of 2x times cos x. This can be rewritten as dy over dx positive y times tan x is equal to e raised to the power of 2x times cos x. Now we need integrating factor, which is e raised to the power of integral p dx. So my p is tan x, so it's e raised to the power of integral tan x dx. This is nothing but integral of tan x is ln of secant x. So the base and the ln, which is natural ln, they get neutralized, giving me secant x, and this is my integrating factor. Now what I wish to do is I will take this integrating factor and I will multiply this equation 2. So this is 2 dy over dx positive y times tan x is equal to e raised to the power of 2x times cos x. So this is my 2. I'm going to multiply 2 by the integrating factor. So what do I get? Secant x times the dy over dx positive y times secant x times tan x is equal to e raised to the power of 2x cos x times secant x. Now cos x and secant x, they get cancelled. Now what is this? This is nothing but differentiation of secant x times y. Right? You apply u into v formula, you get this quantity is got. On the right hand side you get e raised to the power of 2x. Now integrating both sides with the reference to x, this is what you have. Now the differential operator d over dx and the integral operator, they get neutralized, giving me secant x times y. If you were to integrate this is e raised to the power of 2x, the coefficient of x is 2, this is what you get, plus you need to add the arbitrary constant c. So this is the general solution, but we need to get the particular solution. Okay, so let me move on to the next side of the paper. So I'm going to write this here. What is this? This is the general solution, GS. Now to get the particular solution, What is given? We are given when x is equal to 0, y is equal to 3. So substitute x is equal to 0. So this is going to be y times secant x is 1 over cos x, right? And e raised to the power of 2x divided by 2 positive c. I substitute x is equal to 0. So cos, when x is equal to 0, cos of 0 is equal to 1. So this is going to be 1 and y is equal to 3. So 3 is equal to e raised to the power of 2 times 0, it's 1 over 2 positive c. Move this, you get c is equal to 3 negative 1 over 2, 6 negative 1 divided by 2, which is 5 over 2. So therefore c is equal to 5 over 2. So the particular solution, okay, is going to be y times secant x is equal to e raised to the power of 2x divided by 2 positive, this is the value of c, c is 5 over 2. This can be rewritten as 1 over 2 times e raised to the power of 2x positive 5 is equal to y times secant x. We need to only have y. So y is equal to 1 over 2 times secant x times e raised to the power of 2x positive 5, and this is nothing but secant x is 1 over cos x, so I get cos x over 2 times e raised to the power of 2x positive 5 is equal to y. So this is a particular solution. Now one small information I need to add here. Now I just mentioned here as GS, general solution. Now whenever we represent general solution, on the left we need to have only y. So we need to push this secant x down. So that would mean y is equal to 1 over secant x times e raised to the power of 2x over 2 positive c. So secant x is 1 over cos x. So if I were to rewrite this, my general solution is going to be y is equal to cos x times e raised to the power of 2x over 2 positive c. So this will be the general solution. So you can write this. This is the particular solution. The general solution is y is equal to cos x of e raised to the power of 2x over 2 positive c. So this is my general solution. Okay. So now we are given the third condition. Third condition is find the smallest value of x when y is equal to 0. So if I were to substitute 0 here, what would happen? I have to substitute 0 over here, okay, in the special case. So 0 is equal to cos 2x divided by 2 times e raised to the power of 2x positive 5. This would mean cos x times e raised to the power of 2x positive 5 is equal to 0. Now if AB is equal to 0, then either A is equal to 0 or B is equal to 0. Right. So let me move on to this side. So this would mean cos x is equal to 0 or e raised to the power of 2x positive 5 is equal to 0. So this would mean e raised to the power of 2x is equal to negative 5. Now this is not possible because this is exponential value. So you cannot equate it to a negative value. So this has to be dropped. Now cos x is equal to 0. So that means you are expected to find the smallest value of x for which y is equal to 0. So this is only possible when x is equal to pi over 2. So that is the solution for this question. Welcome everybody. We got this question. Use the method of differences to prove that for n greater than 2, sigma r is equal to 2 to n ln of r positive 1 divided by r negative 1 is equal to ln of n into n plus 1 divided by 2. So this is the first part, and then the second part we need to find the value of this summation. So what I will do is I will start with the first part. So foremost, consider the left hand side. So what is on the left hand side? Sigma r is equal to 2 to n ln of r positive 1 divided by r negative 1. Now we know that ln of a over b is equal to ln a negative ln b. So this is going to be sigma r is equal to 2 to n ln of r positive 1 negative ln of r negative 1. What I wish to do is I will like to run the value for r from 2 to n. So when the value of r takes 2, this is going to be ln of 2 positive 1 3 negative 2 negative 1, that's ln 1. Now I will be writing the summation in telescopic form so that you will write r is equal to 3, 3 positive 1 is going to be 4, negative 3 negative 1, that's going to be 2. Okay, fair enough. Next r is equal to 3 is done. Next r is equal to 4. So let me just write that down here. R is equal to 2 and r is equal to 3 and r is equal to 4. When r takes the value 4, you get 5 negative 5, 4 negative 1, that's going to be 3. So this is going to be 6 negative ln 4 and this is going to be 7 negative ln 5. So clearly you can actually see what's exactly happening here, right? This is 7 and exactly over here you get 4. This is 6, exactly over here you get 3. This is 5, exactly over here you get 2. So if you were to continue flowing like this, right, if you continue in this fashion, so what is going to happen here, you are going to get ln of the final value r is equal to n positive 1, that's going to be the value, followed by ln of n negative 1, so that is going to be the value here. Okay, so we started with ln 3, we are ending here, right? Now if you were to cancel out, all of these values will get cancelled and so on and so forth, and finally what would remain would be negative ln 1 negative ln 2 followed by positive value above this ln n and ln of n positive 1. This is what would remain. So if you were to rewrite this, you get negative ln 1 negative ln 2 positive ln n positive ln of n positive 1. Now this is 0, this goes off. We know that ln a plus ln b is ln ab, so this is going to be ln n into n positive 1 followed by ln 2. Now ln of a negative ln b is ln of a over b, so this is going to be ln n into n positive 1 divided by 2. Now this is exactly what is required. You see here, so which is equal to right hand side hence proved, right? So that is the first part. Now let me go to the second part. The second part wants us to find the value. Let me write that. R is equal to, the value starts from 50. I think the value, the question starts from 52. It's not from 50. Let me check that out. The value actually starts from 51. Okay, R is equal to 51. So let me write that down. R is equal to 51 to 100. We are expected to find ln of r positive 1 divided by r negative 1 raised to the power of 35. So we need this value. Now I know a formula, ln of a raised to the power of b is equal to b times ln a. So this is equal to 35 times ln of r positive 1 divided by r negative 1. The sigma r is equal to 51 to 100. I can rewrite this as 35 times sigma r is equal to 51 to 100 times ln of r positive 1 divided by r negative 1. Okay, fair enough. Now we have a formula. Okay, this formula has been proved, so let me utilize that formula. So we know that sigma r is equal to 2 to n ln of r positive 1 divided by r negative 1 is equal to ln of n into n positive 1 divided by 2. we proved this, right? But we need, what do we need? We need sigma r is equal to 51 to 100 ln of r positive 1 divided by r negative 1. This is what is required. Now of course you have a 35 there, right? So the 35 has to be placed there. So we need this. So what I'm going to do is, this is equal to 35 times, I'm going to rewrite this as sigma r is equal to, I'm going to start from 2 to 100 ln of r positive 1 divided by r negative 1. From here I'm going to subtract all values from r is equal to 2 to 50. That means the value that remains would start from 51 to 100. Okay, so that is the understanding. Now we know this formula, right? So let me calculate this. Calculate sigma r is equal to 2 to 100 ln of r positive 1 divided by r negative 1. So what is that? This is equal to ln of n into n plus 1, right? So 100 into 100 plus 1 divided by 2, 2 goes here 50 times. So this is equal to ln of 50 into 101. So this is what we have got. This is the first value. Now also we calculate r is equal to 2 to 50 of ln of r positive 1 divided by r negative 1. So what is that? That is ln of, the value is 50 into 50 plus 1 divided by 2. This is going to be 25 and this is going to be 51. Okay, so we take these two values and we substitute it here. So if I were to take this as 2, so this is equal to 35 into, therefore 2 becomes, substitute this value. So it's going to be ln of 50 into 101 negative ln of 25 into 51. So ln a minus ln b. So this is equal to 35 into ln of 50 into 101 divided by 25 into 51. So this goes here 2 times, right? So this is equal to 35 times ln of 2 into 101, right? 2 into 101 divided by 51. So I'm going to write this as negative ln 51. Fair enough, right? Now actually the solution wants us to stop at a times ln of b over c. Right, now I was under the impression that we need to split this further. So what I want to do is, I don't want to proceed here, but I can very well stop here. Now this is going to be 35 times ln of 2 into 101 is 202 divided by 51. So this is the solution for this question. Okay, so I hope you like this solution. We will move on to the next one. Okay, so this is question number 5. We've been given the matrix M is equal to A2, negative 3, 2, 3, 0, 4, A2, where A is a constant. We are expected to show that M is non-singular. So this is first part. Second part is we are expected to find the inverse of this matrix. Now for M to be, so let me start off with the solution. Question number 5, part A is solution. Okay, so for M to be non-singular, the determinant of M should not be equal to 0. That is the requirement. So let us find the determinant of M. This is equal to, I take the first element which is A here, leave the row and the column, whatever that is present here, place it, 3, 0, A2. So we start with positive, follow it up with negative. What's the element there? 2. Leave the row and the column, you got 2, 0, 4, 2. Write that. 2, 0, 4, 2. Next you have positive sign. What you got? Negative 3. You're going to place negative 3. Leave the row and the column. 2, 3, 4, A. 2, 3, 4, A. So this is equal to 2 times 3 is 6. When you flow from left to onwards towards the right end, you take a negative sign with you. So this is going to be a into 0. Negative 2 times 2 into 2 is 4. When you flow from the left end to the top right, you take a negative sign with you. So this is 4 times of 0. Positive into negative, you have negative 3. A into 2 is 2a. When you flow from the left to the top end, you take a negative sign with you. So 4 into 3. So this is a times of 6. A into 0 is 0. Negative 2 times 4 into 0 is 0. So you got the 4 there. Negative 3 times 2a, negative 4 times 3. That's 12. So I'm just going to write that in this fashion. So this is equal to 6 into a, 6a, negative 8, negative into negative 3 into 2a is negative 6a, negative positive 3 times 12 is 36. Positive 6a, negative 6a gets cancelled. This is going to give me positive 28, which is not equal to 0. Now you can write here, since the determinant of the matrix M is not equal to 0, this implies that M is non-singular. Non-singular means what? M will have an inverse. So this means M inverse exists. Okay, that's the meaning of it. Now we are going to show, in other words, we are going to find M inverse. So what is the formula for M inverse? We know that M inverse is equal to 1 over determinant of M multiplied with adjoint of M. Okay. Now first we know determinant of M. So determinant of M is 28. We need to find the adjoint of M. Now adjoint of M is nothing but cofactor of M. You have to take the transpose. Okay, that is the formula. So we need to get the cofactor for all the elements of the matrix M. So how do we do that? We need to first find out the minor, okay, of each element A. So we need to get that value. So to find the cofactor of the matrix, we need to get the minor of each of the elements. So I'm going to write the matrix down. So M is equal to A2 negative 3, 2, 3, 0 and 4A2. 4A2. So we write it like this. Minor of the first element A, we start with a positive sign. Okay, and we leave the row on the column. So what we got? 3, 0, A, 2. So 3, 0, A and 2. So that is going to be 2 times 3 is 6. So that's the minor of A. Next is minor of 2. So we follow it up. This is going to be negative. So you get 2042. Now this is going to be 2 times 2 is 4. Next, minor of negative 3 is going to be positive. You leave the row and the column. So that's going to be 234A. So this is going to be 2 times A, negative 12. So the first row is done. You got to go to the second row. Now minor of 2, positive, negative. Leave the row and the column 2, negative 3, A and 2. So this is going to be negative of 2 times 2 is 4, negative, positive 3 times A. This minor of 3, negative sign. Now you have to have a positive sign. Leave the row and the column A, negative 3 and 4 and 2. A, negative 3, 4 and 2. So 2 times A, negative, positive 12. Now the next is minor of 0, positive, negative. Leave the row and the column A24A. That's negative A squared, negative 8. So let me move on to the next side. So I've got the minor for 4, positive, negative, positive, positive. So leave the row and the column. You get 2, negative 3, 3 and 0. So this is going to be 0, negative, positive 9. So 9 is the value. So the minor of A, positive, negative, leave the row and the column. A negative 3 2 0, 0 positive 3 to the 6, you get negative 6. Next, minor of 2, leave the row and the column, you get A 2 2 3. So 3 times A, negative 4. So this is what you got. So now cofactor matrix you need to write. So the cofactor of M, okay, is equal to, you need to put in all the elements. So I start with the first element, 6 negative 4, and then you have 2A negative 12, negative of 4 positive 3A, 2A positive 12, and then negative of A squared negative 8, and then you got a 9 there, and then a negative 6 and 3A negative 4. So this is the cofactor of M. Now the adjoint of M, see, the adjoint of M is nothing but cofactor of M transpose. So you need to take the transpose of this matrix. So that means all the column will become the row. So this is going to be 6 negative of 4 positive 3A of 9, negative 4 2A positive 12, negative of A squared negative 8, okay, 4 2A, so this is going to be negative 6, and then 2A negative 12, negative of A squared negative 8, 3A negative 4. So this is the cofactor matrix. So the inverse, so therefore M inverse is equal to 1 over determinant of M multiplied with the adjoint of M. So that is equal to 1 over 28. Determinant is 28, right? So 1 over 28 of this matrix, 6, or I would say the elements there. So 6 negative of 4 positive 3A, this is going to be 9, so negative 4, 2A positive 12, negative 6, and 2A negative 12, negative of A squared negative 8, and 3A negative 4. So that is the solution for this question.
Good day everybody. We got a beautiful question. We are expected to express this given expression as partial fraction, and then subsequently in part B we have to integrate the component. So foremost, let me go and solve question in part A. So consider 2x squared positive 3x positive 6 divided by x positive 1 times x squared positive 4. Now the denominator can be rewritten as a over x positive 1 positive bx. Because of the fact that it has x squared positive 4, I can rewrite this as bx positive c over x squared positive 4. So this is the way we represent the left side. Now you cross multiply and you get 2x squared positive 3x positive 6. Now this is equal to, so naturally x positive 1 gets cancelled, giving you x squared positive 4, positive b times x positive c times x positive 1. So now what you need to do is you need to distribute the quantities. So that would give me, on the left side it's going to be 2x squared positive 3x positive 6. On the right hand side it's a times x squared positive 4 times a positive, I multiply this with this, so b times x squared, I multiply this with this, so bx, I multiply this with this, so cx, I multiply this with this, so c. Now I will collect all the x squared terms. So this is x squared of a positive b. Next I will collect all the x terms, x of b plus c. Next I will collect all the constant terms. That's going to be 4 times of a. So constant term is basically there's nothing there to take out in common, so I will just club these two things and place them as it is. Now on the left side it's 2x squared positive 3x positive 6. Now what we are going to do is we will be equating the coefficients of x squared. That's the first thing that we are going to do. So on the left side the coefficient of x squared is 2. On the right hand side you got a positive b. Next we will equate the coefficient of x on the left hand side is 3, on the right hand side is b positive c. Next, equating the coefficient of constant term. So on the left hand side it's 6, on the right hand side it's 4a positive c. So subsequently we have arrived at 3 equations: equation 1, equation 2 and equation 3. So what I'm going to do is I'm going to take these equations and I'm going to solve them. So let me move on to the next page. So you got, let me rewrite it like this: a positive b is equal to 2, and then b positive c is equal to 3, and then 4a positive c is equal to 6. Now what we can do is we can actually solve 1 with 2. So you take 1 and 2 together. So it's going to be a positive b is equal to 2, and then in the column of b you place this b, and in the column of c you place c. I would say column of a you place c. This is equal to 3. Now you change the signs, so this gets cancelled, so you get a negative c is equal to 2 negative 3, that's going to be negative 1. So this is my equation 4. Okay, fair enough. Now what you need to do is you have to get rid of one more term, right? Now what I'm going to do is, from 4 I see that I got 4a plus c. So let me rewrite this as a is equal to negative 1 positive c, and put this in 3, right? So this is going to be 4 times of negative 1 positive c. Positive c is equal to 6. So the objective is to find the value of a, b and c. So this will give me negative 4, positive 4 times c, and a c there is equal to 6. You add this, you get 5c. You move this to the other side, you get 6 positive 4. So 5c is equal to 10. Therefore c is equal to 10 over 5. And 5 divides 10 2 times. So you get c is equal to 2. Now c is equal to 2. You put it in 4. Right? So a negative 2 is equal to negative 1. Push this to the other side. So a is equal to negative 1 positive 2. So a is equal to 1. So I got a, and I need to get b now. So you put this in 1. So I get 1 positive b is equal to 2. Push this to the other side. So therefore b is equal to 2 negative 1. So b is equal to 1. So I've got b is equal to 1, a is equal to 1, and c is equal to negative 2. So go back to the original expression for partial fractions, right? So this is the original one that we have got. I'm going to take this as some alpha, so because I can name them. So therefore what have we done? Alpha can now be rewritten as, so 2x squared positive 3x positive 6 divided by x positive 1 times x squared positive 4 is equal to, a is 1 over x positive 1, b is 1, so xc is 2 divided by x squared positive 4. So this is the solution for part A. Now we need to head on to the second part, okay, part B. Now we are expected to integrate. So integral 0 to 2 times x squared positive 3x positive 6 divided by x positive 1 times x squared positive 4 times dx, and show that to be equal to ln of a times root 2 positive p times pi. Now consider the left hand side. So left hand side is 0 to 2 times x squared positive 3x positive 6 divided by x positive 1 times x squared positive 4 times dx. Now this is rewritten. I got the partial fraction component, right? So it's going to be 1 over x positive 1 positive x positive 2 divided by x squared positive 4 times the dx. Integral is from 0 to 2. Now this can be rewritten as integral 0 to 2 dx over x positive 1 positive integral 0 to 2 x positive 2 divided by x squared positive 4 times the dx. Now you consider integral 0 to 2 dx over x positive 1. Now this is nothing but ln of x positive 1. Limits are 0 to 2. You substitute the upper limit, you get 2 positive 1. Negative, substitute the lower limit, 0 positive 1. Now ln 1 goes off, giving you ln 3. So this is for
this quantity. Now next you consider integral 0 to 2 x positive 2 divided by x squared positive 4 times the dx. This is rewritten as 0 to 2 x into dx divided by x squared positive 4 positive 2 times dx divided by x squared positive 4. Limits are 0 to 2. Okay. Now you can integrate this quantity. So this quantity, consider integral 0 to 2 x times dx divided by x squared positive 4. Now what we can do is we can substitute x squared positive 4 to be equal to some t. So 2 times dx is equal to dt. We have x dx only. So x dx is equal to dt over 2. You don't have to worry about the limits as of now. So just you proceed with the evaluation. So in place of x dx, I'm going to substitute dt over 2. I place a 2 there. In place of x squared positive 4, I substitute t. Now this is nothing but ln of t, okay, with a half there, and t is x squared positive 4. So revert that back. So this is 1 over 2 ln of x squared positive 4. So now you place the limits 0 to 2. Okay, now you apply the limits. So this is 1 over 2 ln of, I apply the first limit, so 2 squared positive 2 squared positive 4, that's going to be 8 there, and negative ln of 0 positive 4, so it's going to be ln 4. So this is what we have got. Now you can either just retain this as it is, or what you can do is you can write it like this. We know that ln of a over b is equal to ln a negative ln b. So by that, this is 1 over 2 ln of 8 over 4. So 4 divides 2 times. So this is 1 over 2 ln 2. Also, we know that ln of a raised to the power of b is b times ln a. So what we have got here, we have got half times ln 2. Now either you can just leave it as it is, or you can take it off to the exponent or to the base over here and then rewrite it. But for the time being, I will just allow it as it is. So this is for this side. Okay. Now go to the other part. The other part is what? Integral. Now consider integral 0 to 2. What have we got? We got 2 times dx. So 2 times dx divided by x squared positive 4. I'm going to rewrite this as 2 times integral 0 to 2 dx over x squared positive 2 squared. Now you have a formula. Integral dx over x squared positive a squared is 1 over a tan inverse of x over a. Okay. Using that formula, this is going to be 2 times of 1 over 2 tan inverse of x over 2. The limits are 0 to 2. So I substitute. In fact, 2 and 2 can be cancelled. So I substitute the upper limit, I get tan inverse of 2 over 2. I substitute the lower limit, I get tan inverse of 0. Now tan inverse of 0 gets cancelled, 2 and 2 gets cancelled, giving me tan inverse of 1, which is pi over 4. So now you need to club it. So therefore, the evaluation for this, therefore what? Integral 0 to 2 x positive 2 divided by x squared positive 4 times the dx is equal to, this is the first quantity, 1 over 2 times ln 2, followed by the second quantity, positive pi over 4. So this is one part. Okay, so we need to go to the other part also. So there is this part. So we need to club everything together. Okay, so I need to go to the next. So let me name this as 2. Let me name this as 1. And then I need to join 1 with 2. Okay. Okay, therefore 1 added with 2 is equal to ln 3. You need to add this one. Okay. Plus 1 over 2 times ln 2 plus pi over 4. Okay. Now what I'm going to do is I'm going to club these two together. Okay, I'm going to club these two together. So if I were to club these two together, this is going to be ln 3 plus ln 2 raised to the power 1 over 2 and this is going to be ln 3 plus ln of root 2 positive pi over 4. Now we know that ln of a plus ln of b is ln of ab, so this is going to be ln of 3 times root 2 plus pi over 4. So the requirement, what is the requirement for this question? Let me show you. The requirement of this question is this, right? So what have we got here? We got this. So this is similar to ln of a times root of b positive b times pi, okay, because this can always be rewritten as ln of 3 times root 2 positive b is 1 over 4 times pi. So if they are asking you what's the value of a and b, a is 3 and b is 1 over 4. Good everybody, we got this interesting question in complex numbers. Given that z is equal to a positive bi, a complex number, a and b are real constants, shows that z times z star, or you can say z asterisk, is a real number. Now this is part A. Now part B says z into z star is given to be 18, z over z star is 7 over 9 positive, 4 times root of 2 over 9 times I. Determine the possible complex number z. Okay, so I will start off by doing the part A. We need to show z times z star. So consider the question A, right? Now given z is equal to a positive, I'm going to write it as IB. Okay, it's given as BI, but for the sake of conventionality, I'm going to take it as z is equal to IB. There's nothing wrong with that. So given that z is equal to a positive IB, its conjugate, which we are indicated as z star, is a negative IB. So requirement, what is required? Required to show that z times z star is real. So that is what is needed. So that means there should not be any I there. So now consider z into z star. Z is a positive IB, z star is a negative IB. You multiply this, you get a squared negative IB squared. This is equal to a squared negative I squared b squared, but I squared is negative 1. So this is a squared negative of negative 1 times b squared, which is equal to a squared positive b squared, which is a real number. Okay, so you need to state here, hence proved. So first part is done. Now we need to move to the second part. Now for the second part, let me go to the next side. Now given, what is given? Given z over z star is 7 over 9 positive 4 times root 2 over 9 times I. This is given. So, but z is equal to a positive IB and z star is a negative IB. So if I were to take this as 2, therefore 2 can be rewritten as a positive IB over a negative IB is equal to 7 over 9 positive 4 times root 2 over 9 times I. Now what I'm going to do is I am going to consider the left hand side, a positive IB divided by a negative IB. I'm going to multiply by a positive IB and divide by a positive IB, right? Conjugate multiplication. This would give me a positive IB whole squared divided by a squared. Already we have multiplied this, so this has been found to be as a squared positive b squared. Numerator, so that's going to be a squared positive 2 times I times AB, and you square IB, you get I squared and b squared. I squared is negative 1, so this is going to be b squared with a negative sign divided by a squared positive b squared. I can rewrite this as a squared negative b squared positive I times 2ab divided by a squared positive b squared. So this is one part you have got, but actually what we have been given, but z over z star is 7 over 9 positive 4 times root 2 over 9 times I. This is what we have got, and this part is z over z star, right? So equating the real part and imaginary part, we get, so this is going to be a squared negative b squared divided by a squared positive b squared is equal to 7 over 9, and this is I times 2ab, so 2ab divided by a squared positive b squared is 4 times root 2 divided by 9. So that is looking good. Go back to the problem. The problem is saying z into z star is 18, but what is z into z star? We have found z into z star to be as a squared positive b squared. So a squared positive b squared is equal to 18. This is given. So if I were to take this as sum 4 and sum 5, therefore 4 can be rewritten as a squared negative b squared divided by 18 is 7 over 9. You cross multiply, you get a squared negative b squared is 7 over 9 times 18. 9 divides here 2 times, so a squared negative b squared is 14. So this is one part. I take it as 6. Now also from 5, what you got? You got 2ab divided by a squared positive b squared. Substitute 18. So 4 times root of 2 divided by 9, you cross multiply, you get 2ab is equal to 18 times 4 times root of 2 divided by 9. 9 divides 18 2 times. 2 times 4 is 8. So therefore 2ab is 8 times root 2. So now I can extract a value for a or b. So I will take the value for b. So from here 2 divides 8 4 times. So ab is equal to 4 times root 2. So b is equal to 4 times root 2. So you can extract either for a or b. So I am taking b is equal to 4 times root 2 divided by a. So this one is going to be 7. What I would do is I would take 7 and I substitute it in 6. Okay, so let me go to the next side. So what we got? We got a squared negative b squared is equal to 14. That is my 6. And then b is equal to 4 times root 2 over a. That is my 7. So I'm going to say put 7 in 6. So this is going to give me a squared negative 4 times root 2 over a raised to the power of 2 is equal to 14. So this is a squared negative 16 times root 2 divided by a squared is equal to 14. So this is what I have got. Now we need to actually extract the values. So if I were to multiply by a squared throughout, then I would get a power 4 negative 32 is equal to 14 times a squared. So this can be rewritten as a to the power of 4 negative 14 times a squared negative 32 is equal to 0. Now if I take a squared is equal to t, I have t squared negative 14 times t negative 32 is equal to 0 using quadratic formulae. So I have t is equal to 14 plus or minus root of 14 squared, negative times negative, that's positive, 4 times 1 times 32. 4 2s are 8, 4 3s are 12. So divided by 2 times 1. 14 squared is 196, 128. So this is 14 and 1, 10, 11, 12, 1, 324. 324 plus or minus root of 324 divided by 2. Okay, now what is 324? That's a very important part we need to know. You multiply 18 with 18, you get 324. So this is going to be 14 plus or minus 18 divided by 2. So this is the value of t. So t will be 14 plus 18 divided by 2, or t will be 14 negative 18 divided by 2. Now from here I get negative 4 divided by 2. So therefore t is equal to negative 2. This is one part, and over here this is going to be 32. So t is equal to 16 here. But what is t? T is nothing but a squared. So a squared is equal to 16 equal to 16. So a is equal to root of 16. So a will be plus 4 and minus 4. Now we need to get the value for b. Also, the value of b, we know that b is equal to, let me get the value of b. So b is 4 times the root of 2 divided by a. Now I'm going to substitute when a is equal to 4. So b is equal to 4 times the root of 2 divided by 4. So I get b is equal to root 2. Now when a is equal to negative 4, so b is equal to 4 times the root of 2 divided by negative 4. So b is equal to negative root of 2. So they are asking us to find all complex numbers. So we know that the form of z is a positive ib. Therefore z1 is 4 positive I times root of 2, and the other possibility, we need to get the other possibility, z2 is equal to negative 4 times positive I times root 2. The other possibility, z3, is 4 negative I times root of 2. This is the other possibility. And z4 is negative 4 negative I times root 2, right? So when a is equal to 4, when a is equal to negative 4, and b is root of 2, when a is equal to 4 and a is equal to negative 4 and b is equal to negative root of 2, right? So we need to list down all the 4 complex numbers, possible complex numbers. So this is the possible complex numbers. Good day everybody, welcome back. Now we've been given this information, z raised to the power of n positive 1 over z raised to the power of n is equal to 2 times cos n theta, where n is element of natural numbers. We are expected to show this left side is equal to right hand side. Now foremost, what I wish to do is I will start off by stating, consider the left hand side. So we got 32 times cos raised to the power of 6 theta. Now I would like to rewrite this as 32 times cos theta raised to the power of 6. Now let me go back to this information that is given. Now we are given z raised to the power of n positive 1 over z power n is equal to 2 times cos n theta. N is element of natural numbers. So if n is equal to 1, we got z positive 1 over z is equal to 2 times cos theta. So therefore from here I can write cos theta is equal to 1 over 2 times z positive 1 over z. Fair enough, right? So if I were to take this as 2, therefore 2 can be rewritten as 32 cos raised to the power of 6 theta is equal to 32 times cos theta raised to the power of 6 is equal to 32 times cos theta is this 1 over 2 times of z positive 1 over z raised to the power of 6, which is equal to 32 times 1 over 2 raised to the power of 6 times z positive 1 over z raised to the power of 6, which is equal to 32 over 2 raised to the power of 6 is 64 times z positive 1 over z raised to the power of 6. 32 divides 64 2 times, so you get 1 over 2 times z positive 1 over z raised to the power of 6. Now what is this? This is nothing but 32 times cos raised to the power of 6 theta. Now I need to expand this, right? So let me show you the expansion. Now to expand this, I would be utilizing the Pascal's triangle. So it starts with 1, 1 and 1, and then 2 and 1, and then 1, 3, 3 and 1, and then 1, 4, 6, 4 and 1, and then 1, 5, 10, 10, 5 and 1. So let me, so this is going to be 2, 3, 4, 5, I need one more, 6. So 1, 6, 15, 20, 15, 6, and you have the other one. So utilizing this, so therefore what have you got? 1 over 2 times z positive 1 over z raised to the power of 6 is equal to 1 over 2 times. So we start with z power 6 positive 6 times z power 5 multiplied with z positive 15 times z power 4 multiplied with z squared positive 20 times z power 3 multiplied with z power 3 positive 15 times z power 2 multiplied with z power 4 positive 6 times z multiplied with z power 5 positive 1 times multiplied with z power 6. So this is what we've got. I hope you're following it. So now what I wish to do, I would like to club these terms. So 1 over 2 times z power 6 with 1 over z power 6. Okay, this is z power 4. Where we got z power 4? Over here. So 6 times z power 4 positive 1 over z power 4 positive 15 times, this is z power 2. Where have we got z power 2? So 15 times z squared plus 1 over z squared. So all these things are off. This is off, this is off, this is off. Now next one is 20 times z. Is there any constant term? There's z power 3, they get neutralized. So we don't have anything. So just 20 there. So this is what we've got. So now I need to move to the next side. Now I need to get this value, right? Now this value is easily got from over here. Okay, so how do I'll write it here. We know that z power n positive 1 over z power n is equal to 2 times cos n theta, where n is element of natural numbers. So I have that in mind. So therefore for n is equal to 6, so what is this? Z power 6 positive 1 over z power 6 is equal to 2 times cos 6 theta. Now n is equal to 4, z power 4 positive 1 over z power 4 is equal to 2 times cos 4 theta. Now z squared is there, you need to get z squared. So n is equal to 2, z squared positive 1 over z squared is equal to 2 times cos 2 theta. So therefore if I were to take this as sum 3, I can rewrite 3, right? So therefore 3 can be rewritten as, so this 3 is going to be rewritten. Okay, I'm going to rewrite this. So that is going to be what? 1 over 2. In place of this, substitute this 2 times, okay, cos 6 theta. So that is what we have got. Okay, and positive 6 times, in place of this, what we got? We got 2 times cos 4 theta positive 15 times. So in place of this, we substitute this 2 times cos 2 theta plus 20 has to be there. Now you distribute 1 over 2 inside, so this would give me cos 6 theta, but 2 gets cancelled, so 6 times cos 4 theta and 2 gets cancelled, 15 times cos 2 theta plus 2 divides 20 10 times. So this is what is obtained. Now what is on the left hand side? Now on the left side, see, we started with this component, so let me show you on the left side. Okay, so this is what is on the left side. Okay, so now take it back and place it there. So on the left side, what you got? You got 32 times cos raised to the power of 6 theta is equal to this requirement. Now what is the requirement for this question? Show that left side is equal to right side. Now go and see the right side. What is on the right hand side? This is exactly what is required. So hence proved. Okay, that's the first part. Now we can go and do the second part. Now in the second part we are given a graph. Okay, now this is the rough image of the graph that is given, and we have given a function y is equal to h times cos cubed of x positive 4. Now h indicates the height. Okay, now this is a 1 mark question. H indicates the height, and clearly in the question it is given as the maximum height is equal to 2. So they are asking you to find the value of h given this figure. right? Now this is generated by rotating a disk. Okay, the description is given in the question. I am placing the question on the screen. You can watch the screen. Now, given this function and h is the height, and it is given in the question that the maximum height is 2, they're asking us to find the value of h. So from the information, h is equal to 2. So that is a 1 mark question. So this data that I've given you is sufficient enough to get that 1 mark. So h is got. Now let's move on to the next part. Now in the next part, they are asking us to determine the volume. So the volume has to be obtained. Now volume is equal to 1 over 2 times pi y squared times dx. So we need to integrate this. If we integrate this, the limits are given to be as -4 to 4. We will get the volume. But my value of y is h times cos cubed x over 4, and h is equal to 2 units. So y is equal to 2 times cos cubed x over 4. So you need to substitute this over here. Now this is the formula we will be utilizing. So therefore v is equal to 1 over 2 pi, I can take it out, -4 to 4. My y is 2 times cos cubed x over 4 raised to the power of 2 times the dx. So this is 2 squared. So 4 over 2 times pi, limits -4 to 4, 3 and 2. So this is cos 6 x over 4 times the dx. Now let me take x over 4 to be equal to theta. Dx over 4 is equal to d theta. So dx is equal to 4 times d theta. And when x is equal to 4, theta is equal to 1, x is equal to -4, theta is equal to -1. Substitute that. So 2 divides 4 2 times. So this is 2 pi, limits -1 to 1, cos 6 x over 4 is theta, times dx is 4. So 4 times 2 is 8, and you have a d theta there. So you need to integrate this. But we know, what do we know? Let me show this. Okay, this is what we know. So we know that 32 times cos raised to the power 6 theta is equal to this. So I'm going to utilize that concept. I would have to need another paper. Okay, so but we know that 32 times cos raised to the power of 6 theta raised to the power of 6 theta is cos 6 theta, positive 6 times cos 4 theta, and positive 15 times cos 2 theta plus 10. Okay, so this is what we have got. So from here, cos 6 raised to the power of theta is equal to 1 over 32 times cos 6 theta, positive 6 times cos 4 theta, positive 15 times cos 2 theta, positive 10. Okay, now we take this and we substitute this over here. I need to use another sheet of paper. So therefore if I were to take this as 4, therefore 4 can be rewritten as 8 pi -1 to 1. In place of this I will be substituting this. So 32 goes over here. So this is cos 6 theta, positive 6 times cos 4 theta, 15 times cos 2 theta, positive 10 times d theta. Instead of taking it as -1 to 1, I will just take it as 2 times from 0 to 1. Okay, so you substitute the upper limit. So this one would become pi over 2, and this is going to be sine 6 over 6, positive 6 over 4 sine 4, positive 15 over 2 sine 2, positive 10, and I get 5.235. Oh, it should be cubic units because we are dealing with V. So V is equal to cubic units. So we got question number 9. Part A, we are asked to explain why integral 0 to infinity cos x dx is improper. Right, this is what is given. Why is it improper? Why is it improper? The explanation answer is the integral is improper because of the fact that the integrand is integrated between the limits 0 to infinity. So that is the reason this is improper. Next one, show that this is divergent. Part B, integral 0 to infinity cos x dx should be shown to be as divergent. Now you integrate this, you get sin x, right? The limits are 0 to infinity. But what is sin x? Sin x is e raised to the power of x, negative e raised to the power of negative x divided by 2. So if I were to take this as 2, therefore 2 can be rewritten as e raised to the power of x, negative e raised to the power of negative x divided by 2. The limits are 0 to infinity, which is equal to 1 over 2 times. You substitute the upper limit, right? This is upper limit minus lower limit, e power 0 negative e power negative 0, right? Now this one will vanish, so this one will also perish. You got e raised to the power of infinity. Now e raised to the power of infinity is infinity, so that would mean we have shown that this implies integral 0 to infinity cos x dx is divergent. Okay, that's a conclusion. You follow me? But you will have to show all of this. You can either show it like this, or you can utilize limit concept, right? I have applied the limits and I have shown you, but you can also apply limit concepts. Okay, fair enough. Now the next part is, let me go to the next part. This is part C. Part C is 4 times, this is given, is equal to p times cos x. P is a constant. P is a constant, and we are asked to find the range of P. So how do we do this? I'm going to rewrite this as e raised to the power of x, negative e raised to the power of negative x divided by 2. P times e raised to the power of x, positive e raised to the power of negative x divided by 2. Now 2 gets cancelled, so you have 4 times e raised to the power of x, negative 1 over e raised to the power of x. On this side, this is p times e raised to the power of x, positive 1 over e raised to the power of x. Now this is 4 times e raised to the power of x, the whole squared negative 1, divided by e raised to the power of x. This is p times e raised to the power of x, the whole squared positive 1, divided by e raised to the power of x. Now this and this can be cancelled, so you have 4 times e raised to the power of x, the whole squared negative 4, is equal to p times e raised to the power of x, the whole squared positive p. You move the p term this side with e raised to the power of x the whole square. So 4 times e raised to the power of x the whole square, negative p times e raised to the power of x the whole square is equal to p. This one is going to be positive, right? So I take e raised to the power of x the whole squared out. I get 4 negative p. I get p positive 4. So I'm going to write this as 4 positive p, and this is e raised to the power of x the whole square of 4 negative p. So you push this down, you get e raised to the power of x the whole squared is 4 positive p divided by 4 negative p. So e raised to the power of x is equal to square root of 4 positive p divided by 4 negative p. Now clearly 4 negative p cannot be equal to 0, and this should always be greater than equal to, it should be greater than equal to 0, but it cannot be equal to 0 because of the fact you got e raised to the power of x, so it's strictly greater than 0. Okay, so if you were to draw the number line, now this is negative 4, this is 4. Now if I were to take the value of p beyond 4, that's negative 5, I will get a negative value. 4 negative 5, that's negative, so this is contradictory to the left hand side, so that's not possible. Now if I were to take a value beyond this 4, let's say 5, this will produce me a negative value. That's again a contradictory. So p, if I were to take it as negative 4, it will perish, right? But we cannot have it perished because of the fact this is strictly greater than 0. So the point is p cannot be equal to negative 4 and p cannot be equal to 4. P equal to 4, then this is again a contradictory to the fact that 4 negative p is not equal to 0. So this cannot be also taken into account. So that would mean P is going to be between this -4 and P. So the solution, let me just, for the lack of space, solution, what is the solution? The range is P is strictly, okay, in this domain. P is greater than -4 but less than 4. So that will be the solution. So we have solved that question. Let's move on. Now this is the last question. I am just representing the part A. Then after completing part A, I will go on to show you part B and complete this question off. So this is question number 10. Now we have a pendulum in motion, and that is modeled after a differential equation, and that equation is given here. We are expected to prove that theta is equal to 1/12 times t times sine 3 theta is a particular solution for this differential equation. So that is our first challenge. So foremost, what I wish to do is I would like to differentiate this with respect to t. So that's going to be d over dt of theta is equal to 1/12 times u into v. So t times differentiation of sine 3t, that's cos 3t, coefficient of t is 3, so I multiply it, positive sine 3t, differentiation of t is 1. I'm going to rewrite this as 3 times t times cos 3t positive sine 3t. Now this is my d over dt of theta. Now I would like to differentiate this again, okay, because of the fact I got d squared theta divided by d theta squared, dt squared. So this is going to be d over dt of d theta divided by dt. I'm differentiating it again. 1/12 is a constant, take it out. 3 is a constant, apply uv method. Differentiation of sine t is negative, differentiation of cos 3t is negative sine 3t, coefficient of t is 3, so I multiply by 3, followed by a positive sign, and then cos 3t, differentiation of t is 1. Now all of these things should be inside the parenthesis, so that 3 is multiplied, followed by differentiation of sine 3t is going to be cos 3t, and coefficient of t is 3, so place that. This is equal to 1/12 times, now you distribute 3 inside, so it's going to be negative 9 times t times sine 3t, positive 3 times cos 3t, followed by 3 times cos 3t. So this is equal to 1/12 times, I add these two things, I would get 6 cos 3t negative 9 times sine 3t. Don't bother taking anything out, just leave it as it is. So this is my d squared theta divided by dt squared. Now go back to the question 1. So therefore 1 can be rewritten as, because our objective is to show that theta is a particular solution, that's the reason we are doing all this thing. So in place of this, substitute this over here. So that's going to be 1/12 times 6 times cos 3t negative 9t sine 3t, and then followed by 9 theta, 9 times theta. What is theta? Theta is t over 12 times sine 3t is equal to right hand side. Right hand side is what? 1/2 times cos 3t. Now simplify this. Distribute 12. If I were to distribute 12, I would get 1/2 times cos 3t, and then 3 goes here 3 times, 3 goes here 4 times. So 3/4 times t times sine 3t, positive 3, you distribute 9, so it's going to be 3/4 times t times sine 3t is equal to right hand side. Okay, now both of them can get cancelled, right? So what do you got here? 1/2 times cos 3t. What do you got here? 1/2 times cos 3t. Okay, so left hand side is equal to right hand side. This means theta is equal to 1/12 times t times sine 3t is a particular solution. So that is the proof for the question. So it's a lovely question. Of course it's a challenging question, so I have done the first part, so you got the other part to do. Let's go on.
Now next we are asked to find the general solution. So for that we need to solve the homogeneous equation. So what is that? That is d squared theta divided by dt squared positive 9 theta is equal to 0. Now we need to get the characteristic equation. So that is given as, now you can either use m or r. I will use r squared positive 9 is equal to 0. So from here r squared is equal to negative 9, r is equal to root of negative 9, which is root of 9i squared. So that's going to be plus or minus 3i. So we got a complex form here. So therefore the homogeneous solution is going to be c1 times cos 3. You can use c1 or c1 and c2 or a and b, so that is not an issue, but since we are dealing with constants I prefer to use c1. So c1 times cos 3t positive c2 times sin 3t. So this is the general solution. Let me write this. The general solution of the homogeneous equation, but we need the general solution, right? So therefore the general solution is the general solution of the homogeneous solution plus the solution we got as the particular solution. So these two things should be added together. So this is equal to c1 times cos 3t positive c2 times sin 3t positive. Now this one has been found to be as 1 over 12 times t times sin 3t, right? You see that this has been verified. Okay, so fair enough. So this is my general solution. It can be represented as theta. So that completes that part. Now we got the next part to do. Now we have been given two information. That is, initially, this is a very important word, the pendulum makes an angle of pi over 3 radians with downward vertical. Okay, that's one point. The next point is at rest. So we will have to use these two components. So probably I'll write it as 1 and write this as 2. And using these two informations, we will have to get the value of the constant C1 and C2. So I'm going to write that data here. When theta is equal to 0, or I would say, I think this is the best point, at theta of 0 we are given pi over 3, the angle created, and then we are also given d theta over dt at 0 to be equal to 0. So these two information I will utilize. So we know theta is equal to this information, so I'm going to take this as say some 5. So when I will say theta of 0 is equal to pi over 3, that means this would be a better representation, because when I say at 0 I am talking about t being equal to 0. So that is what we need to do. So this is going to be pi over 3 is equal to c1 times cos of 3 of 0 positive c2 times sin of 3 of 0 positive 1 over 12 of 0 times sin of 3 of 0, right? So t takes the value 0, but theta takes, at t is equal to 0, the value of theta is pi over 3. So that's the understanding. So this goes up, this goes up, this will give you 1. So therefore the constant C1 is pi over 3. Okay, fair enough, that is got. So this is obtained using the first information. The next information is applicable only when I differentiate. So I need to differentiate this quantity. So let me do that. So we know that. So what do we know? We know that theta is equal to c1 times cos 3t positive c2 times sin 3t 1 over 12 times t times sin 3t. So d theta over dt is equal to, differentiate this, you get sin 3t times 3, there's a c1 there, but you need to have a negative sign. Differential of this is cos 3t, 3 is there, and you have a c2. I would say u times v, product rule. So it's going to be 1 over 12 times t times cos 3t, you have a 3 there, plus sin 3t. Okay, fair enough.
So now this is going to be producing 0 at t is equal to 0. So at t is equal to 0, d theta over dt is equal to 0. So this is equal to 0. Negative 3 times, this is t is equal to 0. So this goes off. This is going to be 1. Okay, fair enough. Plus 1 over 12 times. Now t is equal to 0. So this also goes off. And what happens here? This also goes off. Everything is 0. So this means C2 is equal to 0. Okay. So therefore my general solution theta is pi over 3 cos 3t positive 1 over 12 times t times sine 3t. So this is a beautiful solution that we have got. But this is not the end. Why? We need to go back and see the question. So let me write that question down. Now this is the next part. Given 10 seconds after it began, the pendulum makes a certain angle alpha. If alpha is given to be a 0.62, we are expected to evaluate the model. So for that, foremost what we need to do is we need to go to this given equation. So let me just take it as 6. So at t is equal to 10 seconds, we are expected to find alpha. In this case, we need to get this output. So what I'm going to do is I'm just going to say theta is equal to pi over 3 cos of 3 times of 10 positive 10 over 12 times, because t is 10, sine of 3 times of 10. Now this is going to be pi over 3 cos 30, right? Cos 30 positive 2 divides here 5 times, 2 divides here 6 times. So this is going to be pi over 3 cos 30 is root 3 over 2, 5 over 6, and sine 30 is 1 over 2. So this is equal to root of 3 times pi divided by 6 positive 5 times of 12. Now if you calculate this using the calculator, this will be approximately 0.62. Now how are you going to conclude? Because you have got this value 0.62, you will have to make the following conclusion. Since the true value of alpha is given to be as 0.62 and our calculated value is 0.62, the model is accurate. The model is accurate and reliable. You have to state these two words. These are the two important keywords, followed by the third keyword for predicting the angle alpha after 10 seconds. Now you have to write down all of this, very important. Okay, if you slip anything, if you slip these keywords, skip these keywords, you won't be awarded full marks. So this conclusion is very important. So let's go move on to the last one. Okay, the last part, we are asked to refine the differential equation of, or I would say the differential equation that is governing the motion of the pendulum to a simple harmonic motion. So SHM. Now you have to know the form of the simple harmonic motion. The general form of simple harmonic motion is given by d square theta divided by dt squared positive omega square theta is equal to 0. This is the general form, where omega is the angular frequency of the oscillation. Now we are given, what are we given? We are given d square theta over dt squared positive 9 theta is equal to 1 over 2 times cos 3 theta. This is what is given to us as a differential equation of the pendulum. Now for this to represent this, you can write this. For the given differential equation to represent SHM, we need to remove what you call as the forcing term. We need to remove the forcing term 1 over, this is called the forcing term, 1 over 2 times cos 3t. Okay, this has to be removed. Thus the refined differential equation is d square theta divided by dt squared positive 9 times theta is equal to 0, where omega squared is equal to 9. So that is the final answer that you will have to give. And this is a beautiful question. The last question, question number 10, is really a high powered one. Thank you. Please like, share and subscribe.